Hello, and welcome to this Tech Talk, where you will learn about Sailor, a UAV-mounted hostile fire detection system developed by Triton Systems. In this presentation, I will describe the technology, explain what sets it apart from existing solutions, and define the path toward commercialization. Triton Systems is a small business in Chelmsford, Massachusetts, with over 100 scientists and engineers, and several state-of-the-art laboratories in a secret-level cleared facility. Triton has created over $2 billion in shareholder value over the past 15 years and earned the Tibbets Award in 2016 for successful development and transition of impactful technology. Triton has a strong track record of commercializing technologies derived from SBIR funding, including nickel-free conductive filler used on F-35 aircraft, pressure-sensitive adhesives used on F-22 aircraft, and microstructured biosensors for blood pressure monitoring, which led to a successful spin-off company. Triton also has an ongoing effort to develop low-cost, long-endurance UAVs for swarm missions. Triton's Sailor was developed to satisfy the Navy's need for an autonomous hostile fire sensor with low size, weight, and power consumption, which could be integrated with small UAVs to actively surveil large regions of the battlefield. The device will detect gunfire based on the optical signature of the muzzle flash and will relay the location of the gunfire as well as its friend or foe classification to the operator. The specific performance metrics identified by the Navy include sub-50 millisecond time from gunfire to detection, over 90% detection probability with near-zero false alarm rate, angular resolution of geolocation below 5 degrees, detection range of at least 500 meters for small arms fire, and consistent performance across environmental conditions. The successful development and deployment of this technology will enhance soldiers' ability to quickly respond to threats on the battlefield. When a unit comes under enemy fire, it is imperative to quickly determine the enemy's location. This task is often difficult, especially in urban settings where a shooter's location may be obscured. While it is possible to analyze the light or sound produced by the gunshot to determine its location, no low-swap solutions have been demonstrated. Acoustic detection systems require several microphones with substantial separation distance and suffer from signal clutter due to strong surface reflections. Infrared cameras are another promising alternative, but these require bulky cooling systems and exhibit low frame rates relative to the millisecond-long muzzle flashes produced by small arms fire. Sailor provides a uniquely low-swap solution using an innovative optical design. In operation, Sailor will surveil a large area of the battlefield from a small UAV. Upon observing a muzzle flash, Sailor will quickly determine the location of gunfire and the type of weapon used, and will communicate this information to the operator through the UAV's data transmission system. If the operator is observing a camera feed from the UAV, the location of hostile fire may be marked on the video feed. This allows the UAV operator to quickly relay information to nearby troops, who can immediately respond to the threat. Sailor enhances situational awareness and threat response speed, and reduces the potential for friendly fire incidents. We have discussed the operational advantages that Sailor provides, but how does it work? Most of the light emitted by a muzzle flash is in the infrared wavelength band, invisible to the human eye. Our technology uses lightweight, nanostructured flat optics and wavelength-selective multi-channel photodetectors to capture the infrared light from the muzzle flash and determine the direction it came from. We use a high-speed signal processing chain and advanced machine learning models to quickly detect and analyze each muzzle flash. Through innovative design and state-of-the-art technology, Sailor rapidly determines the bearing to hostile fire events and analyzes the muzzle flash signature to identify the type of weapon used. This is all accomplished in a small package with low weight and power consumption, allowing maximum flight time for the UAV platform. This timeline depicts our progress through the end of 2024 and our anticipated development schedule through low-rate production. During our Phase 1 effort, we developed a proof-of-concept, benchtop version of our system, evaluated by observing the flash from the ignition of a handheld lighter. In Phase 2, we have integrated the system electronics into a PCB, fabricated and tested the flat optics, and recorded muzzle flashes from various firearms at close range. By the end of Phase 2, our system will be able to detect muzzle flashes autonomously and determine their position. During the Phase 2 option, we will integrate our system with commercial UAVs and demonstrate autonomous muzzle flash detection during flight. By the end of the option period, the system will be able to operate at the target height of 500 meters, and we will demonstrate its performance at a government-sponsored test event. During Phase 3, we will work with an appropriate program of record to develop requirements, qualify our system, and begin low-rate production of Sailor. Once Sailor is fully developed and tested, it must be integrated into unmanned systems, which are then deployed by the military. To this end, Triton will work with a program of record to develop requirements as well as UAS primes to integrate Sailor into their platforms. Triton will manufacture Sailor through low-rate production and sell systems to UAV manufacturers, who will integrate Sailor into their UAVs, which are then sold to military customers. We plan to showcase our technology at the Sea Air Space Conference in April 2025. Our primary transition advocate is Richard Lamarca of the Naval Air Warfare Center Aircraft Division, and we are open to additional transition advocates and partners. Our analysis indicates that the current market would be very receptive to a hostile fire detector with Sailor's capabilities. Sailor enhances situational awareness and allows rapid threat response in any setting where firearm attacks are a concern. With its low swap and high value in a battlefield context, Sailor could be integrated into a large fraction of the 10,000 UAS fleet operated by the DoD. In a broader context, the tactical UAS market is projected to reach $7 billion by 2028. Sailor's application space also extends far outside the military. Government and private organizations undertaking security and surveillance efforts would benefit from Sailor's integration into small commercial UAVs. Our anticipated business model is as follows. We will work with a POR, such as the Navy and Marine Corps Small Tactical UAS Program Office, to develop requirements and work with UAS primes, such as AeroVironment, Honeywell, and AAI, to integrate Sailor on their platforms. We will manufacture Sailor and sell systems to primes, who will integrate Sailor into their UAVs. The UAVs will be supplied to the military as a single package with an integrated hostile fire detection capability. As our sales and production rates grow, we will likely transition production to a dedicated UAV payload manufacturer. Sailor's transition path is expected to begin with the Navy and Marine Corps, followed by other agencies within the DoD as Sailor's value to the warfighter is demonstrated. We will then expand into non-military security and surveillance applications, with users in law enforcement, security contractors, FBI, DEA, CBP, and others. If you are interested in partnering with Triton or learning more about Sailor, please reach out to Brady Gunnarsson at the phone number below or visit tritonsystems.com. Thank you for your attention.